All right, y'all. So like I said, 7.5, analyzing graphs of quadratic functions. Okay, so let me draw a little parabola here because that's what we're going to be playing with today. So let's see, say I had a parabola sitting in here. And y'all, what we're concerned with on our parabola are these points right here. Now, remember, the parabola can be flipped over. So what we're concerned with is this point right here. We call that the vertex. Okay, so let me define what the vertex is. So the vertex of a parabola is the minimum or maximum point of the parabola. Now, there's a few things that this vertex point tells me. The x value of the vertex gives us the line of symmetry. So what I mean, that x value gives us a line of symmetry. And what that does is it cuts my parabola in half. So that line of symmetry, if I fold my graph over that line of symmetry, it will land on itself. So it's similar to the stuff when we were doing the symmetric to the y-axis. Okay. So the x value of the vertex gives us the line of symmetry, and the y value of the vertex gives us the minimum or maximum y value. So it gives us the minimum or maximum y value. Okay. So we got a formula we use to find the vertex. So the vertex formula now remember, this vertex point is a point on the graph. So when we look at the vertex, it is going to be an ordered pair. So to find that vertex, first we figure out what is negative b over 2a equal. So negative b over 2a will give me the x value. To get the y value, I find f of negative b over 2a. What this means, f of negative b over 2a, that means once we find our x value, we plug that x value back into the function to get the y value. Okay. So different things. Like I said, the line of symmetry. And they might call it the axis of symmetry, either way. So that could be the axis of symmetry. Axis of symmetry is going to be an equation in the form of x equals a. So whatever I get from my x value on the vertex, that x value will be the line of symmetry, okay? Also, a few things that tell me whether I got a minimum or maximum. If the x squared term is positive, if the x squared term is positive, then your graph will have a minimum value. If the x squared term is negative, then we will have a maximum value. Because remember, when you throw a negative in front of a function, it flips it over the x-axis, okay? So we look at that x squared term to determine whether we actually have a minimum or maximum. All right, y'all, so I'm going to pull up MathLab just for a second for one question. So give me a second to pull that up. All right, almost there, having to go through Blackboard real quick. All right, also I'm going to do a new share. All right, let me make this just a little larger for us. All right, y'all, so y'all should be seeing my graph here. So this one, we're just going to look at the picture just to get an understanding of what's happening, and then we'll start using our formula to actually finding these vertexes. So on this graph, we're looking for the vertex, which is the minimum point on here. So y'all, if you notice, the bottom of my graph is touching that x-axis. It looks like it's touching it at -3. And you see that point they got, -3, 0? That's showing me that that vertex is at that -3, 0. So I would put -3, 0. Now remember, you got to put it as an ordered pair in parentheses. So on this one, you just check the answer. The axis of symmetry. Well, remember, we just said that the axis of symmetry is equal to the x value of that parabola, of that vertex point. So my vertex is at -3, 0. So the x value is -3. So when you punch in the axis of symmetry, you got to put x equals -3. Okay, so it's got to look like an equation. You got to have that x in it. So then you would check that answer. And then it says, what is the minimum or maximum value of the function? Well, remember, the minimum or maximum value of the function is equal to the y value of that vertex. So my smallest y value is the y value of the vertex, which is 0. So you're going to put in your 0, check that, and be done. So they're basically just giving you that one so you can get familiar with this vertex. So what we're going to do is we're going to work some examples on finding our vertex, okay? So y'all, they're giving us f of x equals x squared minus 8x plus 7. They want us to find the vertex. They want us to find the axis of symmetry. Determine whether there's a max or min value. And then they want us to graph. Okay. So I will say they're picky on the graphs. When you graph these in MATLAB, we must graph the vertex as the first point. Okay, so they are picky on this one since we're playing with the vertex. When we graph this in MATLAB, it has to be the first point you plot, okay? And then remember, you're going to choose that U-shaped parabola tool on this. So the first thing we're going to do, we're going to find the vertex. Now remember, my vertex formula was negative b over 2a, and then f of negative b over 2a. So we're going to get the x value first. So to get that x value, I'm going to do negative b over 2a. So y'all, I got to figure out a, b, and c. So for my problem, a is going to be 1. Since there's no number in front of the x squared, we treat it like a 1. B will be negative 8. And C will be 7. So same thing as the quadratic formula. You want these in order, and then x squared gives you the a term. X term in the middle gives you the b, and then the number at the end is your c. So let's do this. Negative b over 2a. That's going to equal negative times my b, which is negative 8. So y'all, just like the quadratic formula, that negative b, all it's doing is changing the sign of the b. So if my b is negative, that's going to turn this thing into a positive. And then on the bottom, I got 2 times a, which is 1. All right, y'all, so here we go. Negative times negative makes that a positive 8. 2 times 1 is 2. And then 8 divided by 2 gives us 4. So at the moment, on my vertex, I know the x value is going to be 4. So what we got to do now is come in and get the y value. So the y value says f of negative b over 2a. Well, since negative b over 2a gave me 4, I'm finding f of 4 for this function. So remember, f of 4 means I'm going to take this function and put a 4 in for both of these x's. So that's going to give me 4 squared minus 8 times 4 plus 7. All right, y'all see what we got. 4 squared is 16. 8 times 4 gives me minus 32 plus my 7. All right, y'all. 16 minus 32 is a negative 16. Negative 16 plus 7 gives us a negative 9. So my y value of my vertex is negative 9. So for part A, the vertex is the point 4, negative 9. So then they say, hey, what's your axis of symmetry? Well, remember, the axis of symmetry is going to be an equation, and it's going to be x equals. So y'all, what would y'all put there? X equals what?
4.
4, there you go. Because remember, it's always going to be that x value. All righty. Let's see. Then they want to know if I got a maximum or a minimum. And then we'll tell if it's what that value is. So the first thing to figure out if you got a maximum or minimum, you're looking at this x squared term here. This x squared term is positive. And we said when the x squared term was positive, we were going to have a minimum because that's going to be a U-shaped graph. So we have a minimum value. And do y'all remember what my minimum value would be?
Negative 9.
It's going to be negative 9. All righty, y'all. Then it said graph it. So now if I was graphing this in MATLAB, let me draw my graph here. All righty, y'all. So let's go. I'm going to go out about 10 each way, I guess. There's 5, 6, 7, 8, 9, 10. And then the same thing going down. Now that was my x-axis and my y. All righty. So in MATLAB, you're going to choose your quadratic x squared tool. It'll have 2 dots on it. But y'all, this has to be the first point we plot, which is our vertex, which is 4, negative 9. So we're going to go right 4 and then down negative 9. Now, y'all, so the first point I plotted was my 4, negative 9. Now, I can pick any other point I want. So you can factor that and try to find where the zeros are. You can plug numbers into that and see what you get. So an easy thing that I do on these, I always use 0 for my x's, because that'll give me a point that's on this y-axis. And if you use 0 for the x's, that x squared will be gone because that 0 squared is 0. 8 times x is 0. So 0, 0, and 7 is going to give me a 7. So this last number here is always going to be the y-intercept. That's where it's crossing that y-axis. So if I go up to 5, 6, 7, put my second point, at that point, y'all, Math Lab is going to come in and draw our point going through them 2 points that we put on there. So mine's not too U-shaped looking, but let me do one of these on Math Lab and we'll sort of see how to graph it, okay? So I'm going to go back to Math Lab. Now it's going to make us start another problem here. So y'all, let's try this one. I'm going to write this one down. What do we got here? F of x equals x squared minus 12x plus 35. Yeah, because I'm going to show you a different way on this one because 35 is a big number and this graph only goes to 10 by 10. So let me share this screen and we'll solve this. All righty, so A for this one is 1, B is negative 12, C is 35. So I'm going to find my vertex first, and I'm going to get that x value. All right, y'all, so that's negative B over 2A. That's going to give me a negative times negative 12 over 2 times my A, which is 1. See all what happens? We get a negative times a negative, makes that a positive 12 over 2. And y'all, 12 over 2 gives me 6. So we know the x value is going to be 6. So then we want to come in and get the y value, which will be f of 6. So we'll put the 6 in for our x's. We'll have 6 squared minus 12 times 6 plus 35. All right, y'all, let's see what that does. 6 times 6 is 36. Minus 12 times 6 is 72. And then add 35. And y'all, I'll tell you a trick on this. When you're at this point, that second number is always twice as big as the first number, and it's always opposite in sign. Okay? So that's just little things you can pick up on these. But 36 minus 72 is a negative 36. Negative 36 plus 35 is a negative 1. So my vertex is going to be 6, negative 1. So y'all, knowing that, what is my axis of symmetry?
Six.
So just remember to put that x equals 6. Okay. All righty. Do I have a minimum or maximum value? Well, remember, for the minimum or maximum value, I'm looking at my x squared term. X squared term is positive. So that means we have a minimum. So once again, this one's going to look like a U-shaped graph. So if the x squared is positive, it's a U-shaped. When I do one later that's negative, it's going to flip it over, okay? All right, so what is that minimum value?
Negative 1.
Negative 1. All right, so now they want us to graph it. So what I'm going to do, I need to find another point. So what I'm going to do, I'm just going to make me a table, and I'm just going to get an X value that's really close to the 6. So I might be using like a 5 or a 7. So y'all, I'm just going to put a 5. I'm going to put a 5 into this, see what I get for my Y value, okay? So I'm going to put a 5 in. I'm going to get 5 squared minus 12 times 5 plus 35. Now, y'all ain't going to lie. I'll show you another way to do this in a second with that calculator. 5 squared is 25. Minus 12 times 5 is 60 plus 35. All right, y'all. So 25 minus 60 is a negative 35. Negative 35 plus 35 is 0. So when X is 5, Y is 0. So I got my 2 points, 6, -1, and 5, 0. So let's go play with Math Lab and answer all their questions. So the first thing they wanted was our vertex. Remember, the vertex has to be in parentheses, and we got a 6 and a -1. So you put your vertex in. We wanted our axis of symmetry. So remember, that has to be X equals, and let's see, y'all told me that was what, 6. Okay, it's got to have the X equals. We said this was a minimum. So A is if it's a maximum, B is a minimum. So we had a minimum, and let's see, y'all told me that was -1. So you put that in. Then it's going to want us to graph it. So I'm going to click to enlarge my graph. We're going to use the tool that says vertical parabola tool. And notice it had them 2 points on it. So that's why I know we need 2 points on this. And you got 2 blue dots. So remember, first, I got to plot 6, -1. So I'm going to go right to 6 and then down to -1. All right. Ooh, that's touchy. So there's, oh, I think I went up too high. Let me see if it'll let me drag that down. Oh, let me clear it, y'all. I messed up. Woo, these graphs are touchy. All right, so 6, -1. Messing me up because that's going by halves. All right, so there's 6, -1. And my second point was 5, 0. So I'm going to come over here to 5, 0. Click that. So notice, once you put the second point, it draws that parabola for you. And then you would save that and be done. Now, if you don't go in the right order, it draws the parabola wrong, okay? Alrighty, y'all. So that's the world of graphing on that. So I'm going to go back to the pad now. All right, so the same thing. This time we're giving us f of x equals 2x squared plus 14x plus 24. All right, y'all, let's see. A is 2, B is 14, C is 24. So I'm going to get the vertex first. So let me get my x value. And we know the x value was -b over 2a. So that'll give me a negative times the 14 over 2 times 2. So y'all, let's see what that does. That's going to give me a -14 on the top. That's going to give me a +4 on the bottom. So remember, I don't want mixed number type answers. So 14 doesn't divide by 4. So the only thing we can do is reduce that fraction down. So 14 and 4 both divide by 2. So I'm going to divide the top by 2. I'm going to divide the bottom by 2. So that I get a -7 over 2. So my x value is a -7/2. And y'all, this is the only problem like this one. This is like y'all's number 3. It's the only one where you're going to have to mess with these fractions, okay? So we're finding f of a -7/2. That's going to equal 2 times -7/2 squared plus 14 times -7/2. And at the end is a plus 24. All righty, y'all. So on this problem, we got to start with that exponent. So bring down that 2. And y'all, when you got a fraction raised to an exponent, the exponent affects the top number and the bottom number. So on top, you got a -7 times -7. That's going to make that a positive 49. On the bottom, you got 2 times 2, which is 4. All right, I'm just going to bring everybody else down at the moment. My next step, I'm going to multiply. So the 2 only multiplies times the top number. The 14 only multiplies by the top number. You treat these like they got 1 on the bottom to multiply by them bottom numbers. So 2 times 49 is going to give you 98 over 1 times 4 is 4. Here I got a positive times a negative. So that's going to be a negative. 14 times 7 is 98 over 1 times 2 is 2. And then I'm going to bring down my 24. And remember, at the moment, the 24 has a 1 on the bottom, just like I was doing here. Treat any number that don't have a bottom as if it's a 1. So now here's the trick. In order to add these 3 fractions, I need a common denominator. And my common denominator will be 4 because that's the smallest number that all 3 of these go into. So your least common denominator is a 4. So 98 over 4 already has a 4 in it. So that's just going to stay 98 over 4. So the next fraction, I need a 4 on the bottom. So to turn a 2 into a 4, I multiply by 2. 2 times 2 gives me 4. That means I need to multiply that 98 times 2 also. So y'all, let me see what that's going to give me. So that is 196. And then this last one, I need a 4 on the bottom of that one. So 1 times 4 is 4. 24 times 4 is 96. So y'all didn't forget how fun these fractions were, right? All righty, so what we're going to do at this moment, the bottom's going to be a 4. I got to figure out what's going to be on the top. So 98 minus 196 is a -98. -98 plus 96 is a -2. And y'all guess what? That negative 2 over 4, if you divide both them by 2, gives me a negative 1/2. So our y value is a negative 1/2. But y'all, let me show you. We got calculators, right? So let me share that screen. So if I was wanting to do this on my calculator, I would do my 2, then put in my negative 7 divided by 2. I'm going to square that. Then I would do plus 14. Whoops, let me go back. I would do plus 14 times my negative 7/2. Close those parentheses. And then I had a plus 24 at the end. So you can punch this in the calculator, hit enter. I get a negative 0.5. But if I want that to be a fraction, I'm going to hit math and enter twice. So now it's going to turn my answer into a fraction. And there's that negative 1/2. So fractions, calculator, don't mind doing those, okay? All righty, so we got negative 7/2 and a negative 1/2. So what is our axis of symmetry?
I got a -1
On what?
on this one we just put in the calculator.
Okay, so let me go back to my calculator. So
I got -1/2 as well.
okay, so negative 1/2 is what we want. I'm trying to figure out how you got a -1. So let's put this in again, okay? So we're going to put in our 2, and then I'm going to use parentheses and put in my negative 7/2. So that'd be negative 7 divided by 2. I think it might have been a sign on what you was doing. All right, close parentheses and square that. Then we had plus our 14 parentheses negative 7/2. And make sure y'all ain't hitting that subtraction, okay? Use them negative buttons. And then at the end was what? A positive 24. Right, then when we hit enter, so I get that negative 0.5, which I know is now going to turn into my negative 1/2.
I'm not sure what it is I'm doing wrong, but I'm still coming up with -1.
Okay, I wish I could see your calculator. So tell me how you're putting that in. So tell me every button you're pushing.
Okay, I'm doing. Oh, let me get back to my screen. Okay, I'm doing. Where did the problem go? Okay,
Mhm.
I'm doing the 2
Okay.
parentheses
Uh-huh.
-7
Uh-huh.
divided by 2,
Uh-huh.
close my parentheses,
Uh-huh.
square it,
Okay.
add my 14,
So add 14.
parentheses,
Uh-huh.
is it -7 over 2?
Uh-huh.
Okay, -7. I wonder if that's what I was doing wrong. Close the parentheses,
So you did
plus
negative.
24.
Uh-huh.
Let's see. And I still got -1.
Okay, so I'm wondering, go to mode, click that mode
Okay.
button, and make sure it's on float.
Okay.
Is it on float?
It's on float.
Okay, so then clear that screen
Okay.
and hit enter.
-1. Okay. When it's on, okay, now let me see. Okay, now I got it.
Okay, so what was the deal?
It wasn't on float.
Okay, because what it was
I
doing,
needed to float it.
when it was doing, it was trying to round it up then and making that 0.5 into a 1. It was rounding it up on us.
Got it.
Ooh, okay, I didn't know. Ooh. There we go.
Is the calculator supposed to stay on float?
I keep it on float unless I'm trying to round to a specific number of digits. But yeah, usually I'll keep it on float. That way it won't round stuff off too soon for you.
Okay, so like just the 0, or do you go up to 1?
So let me show you. So now when I hit mode, I just stay on float. So highlight float,
Oh, okay, I see it.
hit enter where it's flashing on float, and then just clear that screen.
Okay.
And so now it'll round off as many digits as it takes, but it won't turn them 0.5s into 1s and stuff like that, okay?
Okay. I was having a lot of calculator trouble last night. Like I must have repeated the same number like 5 times, and I'm like, I'm done.
Yeah, that's probably what it's doing. Now the only time I would change it, like when y'all was doing them problems with the quadratic formula yesterday, and it said round at 3 decimal places. If you put it on 3, it'll round at 3 decimal places for you.
Oh man, I should have done that.
Then you don't have to say, oh, is this a 5 or greater? Do I round this one up and all that fun stuff?
Yeah, that would have been good to remember.
All righty, y'all. So we're about to find another. Oh, yeah, we finished that. So now let's do this one. F of X. Oh, hold on. I don't know if I did the line of. Oh, we didn't ever do our line of symmetry and stuff. So let me get that back down here. All right, y'all. So the axis of symmetry is going to be X equals what?
-7/2.
All righty. So do we have a min or max value? Well, remember, we're looking at that 2x squared term. 2x squared term's positive. So if you was to graph it, it would look like
Minimum.
So it's a minimum. And what's that minimum value?
-1/2.
-1/2. Now, y'all, when you graph this, just remember on MathLab, when you're graphing this, each of these marks will be in halves. So if you want to graph a -7/2, since the graph will be in halves, just go over -7 times and then down 1 time, and you'll be at that -7/2, -1/2. So let me see if I can do one of these, show you how I'll do that in MathLab. Oh, and you know they would never give me the same numbers, right? So here we go. F of X equals 2x squared plus a 10x plus 9. So first I'm going to find a negative b over 2a. So let's find our points on this one. And then I'll show you how to graph this in MathLab, okay? All right, so I want the x value is going to be negative b over 2a. So my b is 10, so that's going to give me a negative times 10 over 2 times my A, which is 2. So y'all, I get a negative 10 over 4. And this is going to reduce to a negative 5 over 2 once I divide these 2's out. So I get a negative 5 halves. So my X value is negative 5 halves. Now for the Y value, I'm just going to plug that in and use my calculator instead of do this by hand. So I'm finding F of that negative 5 halves. That's going to equal 2 times negative 5 halves squared plus 10 times negative 5 halves plus 9. All righty, y'all. So I'm just plugging that on my calculator this time. So let me go to my calculator on here. And let's plug that in. So we got 2 parentheses, negative 5 halves. Close parentheses and square that. Plus 10 times our negative 5 halves. Close those parentheses. And then we got what, a plus 9. So I'm going to hit enter. So I'm getting a negative 3.5. So let's make that a fraction by hitting math and enter twice. So I get a negative 7 halves. So the Y value is a negative 7 halves. And on this one, it always ends up in halves. So I'm pretty sure y'all's will all end up in halves like mine. All right, y'all. So how about this? Axis of symmetry. What y'all got?
X equals negative 5 over 2.
Perfect. All right, once again, remember that 2x squared is positive, so this looks like a U-shaped graph, which means we have a minimum, and that minimum value is our negative 7 halves. And y'all, on this one, I'm going to plot that vertex first. Remember, I need another point. So what I'm going to do, since my last number is sort of small, my second point, I'm just going to put zeros in for these x's. 0 squared is 0. 10 times 0 is 0. 0 plus 9 just gives me a 9. So when that last number is sort of small, I always use that as my second point because that's the y-intercept. So now let's figure out how to graph that negative 5 halves. So first I'm going to put that vertex in, which was negative 5 halves. And then arrow over and do a comma. And then I had a negative 7 halves. Arrow over and put my parentheses. So make sure you arrow out from under them fractions before you close your parentheses and do your commas. So y'all, that's the vertex we came up with. So you're going to check that. Axis of symmetry, y'all told me was x equaled what, negative 5 halves. Check that one. We said it had a minimum. The minimum value y'all told me was what, -7/2. So here's the tricky part. So I'm gonna click the graph. So I'm gonna grab that U-shaped tool. Oh, and y'all, I might have to find another point because this thing only goes to 5. Oh man, so let me share my screen back. So that's only going to 5 on this. So I got to pick another point because 9's too big. So think about this. This X value, -5/2, that's like a -2.5. If you look at it as a decimal. So what I'm going to pick as my second X is going to be a -2. I would probably try a -2 or a -3, something that's sort of close to this, okay? So let's put a -2 in and see what happens. So it's going to be 2 times -2 squared plus 10 times -2 plus 9. Remember, at that point, if you want to, throw that in the calculator and be done. But y'all watch this. -2 squared is 4. 4 times 2 gives me 8. That's going to be 10 times -2 is a -20. And then plus my 9. So let's see what we get. 8 minus 20 is a -12. -12 plus 9 is a what? -3. So when my X is -2, my Y value is -3. So this will now fit on that graph because remember, there's only went to 5s on this. Woo, so I got my points. Let me try that. All right, so I got my parabola tool. So you see how this graph is marked? It's got a dash in between 1 and then a dash and then 2. Those are going by halves. So what you would do for -5/2, if you start in the middle, since this is broken down by halves, go left 5 units. 1, 2, 3, 4, 5. So that puts me at about -2.5 there. And then I would go down -7/2, which would be 7 down. 1, whoops. Oh, let me cancel real quick. I think I hit the thing. So there we go. Ooh, my keyboard's touchy. So I'm going to go left 5 and then down 7. All right, that's 6 and 7. All right, got that first point. So when it's broken down in halves, use the top number to see how many places you go. Now the next one was -2, -3. So over here to -2, down to -3. Click that, save that, and be done. So y'all are a little tricky on those. So you gotta pay attention to how they're breaking your graphs apart for you, okay?
If we use the calculator to put it in and then do second table, is there any way to figure out where the point goes, the first point?
So let me show you a trick on those. So let me go to my calculator. And on the one I just did, let me show you a trick on it, okay?
I'm not very good with fractions.
Okay, so let me go to y equals, and I'm just going to put in my equation, which was what, a 2x squared. So 2x, square that, plus 10x, and then plus 9. Now, here's the thing. We're looking for the minimum value or the maximum value. So if you want to get that on this kind of graph, you see how it's got that 2 in the front of that x squared? We have to fix the table so that it'll do what we need. So I'm going to hit second window. And you see where it's got that triangle TBL equals 1. Since I have a number in the front, like a 2, I'm going to change this 1 into a 1/2. So whatever number's in the front, you want to make your fraction look like that on the bottom. So if I had thirds in the 3x squared, I would make this a 1/3. If I had, say, 5x squared, I'd make this a 1/5. But y'all's homework should only have 2's on them. So if you'll change that little triangle table to a 1/2. Now let's look at the graph by hitting graph. So you see it's over on that left side where we was graphing a while ago. So now watch this. Hit second graph and go to the table. Now look, all these positive numbers are getting bigger, right? So I'm going to have to arrow the other way. And I'm looking for the smallest y value here, okay? So let's keep going. There's 3. We're going to have to get into these negative numbers, it looks like. But notice how the y values are getting smaller, 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 smaller. And look at that. What's happening? They're starting to go back uphill, right? So can y'all tell that the minimum point is at that negative 2.5, negative 3.5? Are y'all with me on that?
Yes.
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 That's what I'm saying. Negative 2.5, negative 3.5. Now remember, in Math Lab, you actually got to put fractions. So write them two numbers down, negative 2.5, negative 3.5, because that's my smallest value there. And if you'll go back into the main screen, and if you'll punch in negative 2.5 and hit math and enter twice, there's your negative 5/2. And then come in and put your negative 3.5 and then hit math and enter twice. That's going to give you the negative 7/2. So y'all with me on that?
Yes.
Now, if you notice, let me go back to my y equals. So if you got a 2 in the front, you want to change that. Now, if I don't have a 2 in the front, say this was just an x squared, so let me delete that 2. If that was just an x squared, I'm going to go to my table by hitting second table. And I'm going to come back down and turn that back into a 1. Okay. And then I'll just make that what, a negative 3 instead of that negative 3.5. So if you look at the graph, by me changing that, I can go to my table and I can find the minimum value here. So let's see, it looks like it's getting smaller still, smaller. And then it starts going back up. So you're looking for the number that's in between two other numbers to be your minimum value. So since that one I just did had negative 16 as the smallest, both sides had a negative 15. That's telling me that that negative 16 is my vertex, okay? So now I'm going to go back over here and say, let me insert that 2 back. So say we went in here and we didn't change that table to do halves. When I hit second graph, look at my numbers. So remember, we was at negative something. But you see in between the negative 2 and negative 3, they both got negative 3 for the y values. That's telling me that that minimum value is in between those two somewhere, okay? But it's not actually giving it to me. That's why I had to change that into halves. Well, those are a little tricky, ain't they?
Woo.
But y'all, that's the only one that's going to kill us is that one with the fractions. Watch this one. We'll do one more, then I'm going to let y'all take a break. And this one won't be as bad. Negative x squared minus 10x minus 27. So I'm gonna get the x value first. Negative b over 2a will be negative times that negative 10 over 2. This time my a is a -1. So let's see what that gives me. That gives me a 10 on top, -2 on the bottom. 10 divided by -2 gives us a -5. So we know the x value is -5. So now to get the y value, put the -5 in for these x's. Now, y'all, this is where you got to watch out. You got that negative, so write that negative no matter what. Then put your -5 in parentheses and square that. Minus 10 times -5 minus your 27. So -5 times -5 when you square it is a 25, but this negative in the front is going to keep it a -25. Here you got a -10 and -5 that makes a +50. And then at the end is my -27. Remember, at this point, the second number will be twice as big as the first number and opposite in sign. So if you accidentally made this a +25 and then you had +50, that's telling me that one of those would be wrong because these two are always opposite in sign. All right, y'all, -25 plus 50 is 25. 25 minus 27 is a -2. So this one would be -5, -2 for my vertex. What is my axis of symmetry? Any guesses?
-5.
So there you go. X is a -5. So does this one have a minimum or a maximum?
A maximum.
Oh, good job. Because guess what, y'all? X squared term is negative. So since the x squared term's negative, it's going to flip my parabola over, and it's definitely going to be a maximum. What is my maximum value?
-2.
-2. Okay, on y'all, that in the same way. First point I would plot would be -5, -2. And then my second point, I would probably come in and use either a -4 or a -6. And I want to get close to that. So let me use a -4. So -4 would give me a negative times -4 squared minus 10 times -4 minus 27. -4 squared is 16. So that's going to make that a -16. -10 and -4 give me 40. And then minus my 27. Ooh, y'all, let's see what we got. -16 and 40 is 24. 24 minus 27 would give me a -3. So my 2 points I would plot would be my -5 halves and then my -4, -3. Alrighty, y'all. So let's take our break and I'll start us back at about, about 11:15? And we'll play with these some more, okay? Alrighty, y'all. So I'm going to pause my recording. All right, y'all, continuing on. Let me share my screen. All right, y'all. So next you'll have problems that are like this. This one says determine whether the statement is true or false.
Can you move your paper down a little bit?
Oh, did I not move my camera back up? Okay.
No, yeah, you're good. Thank you.
All right, so we're going to determine whether the statement is true or false. So this one says the function f of x equals 4x squared minus 3x minus 8 has a minimum value. So y'all, is that true or false? Does this equation have a minimum or a maximum? And I think I heard the right answer.
Minimum.
Yeah, because that 4x squared is positive, so it does have a minimum like it's saying. So this one would be definitely true. Good job. All right, so let's do that on this next one. So I got 3 of these true or falses, okay? This one says the axis of symmetry of the function f of x equals 8 times x plus 6 squared plus 7 is x equals negative 7. So y'all, the trick on this one is to focus on this x plus 6 in these parentheses. And remember, when I add 6 to my x, I'm attacking the x. Remember, that's going to move me left or right. So the question is, how far left is this going to move it? Well, since that's a positive 6, this graph is going to move left 6 units. So if it moves left 6 units, that's going to put it at negative 6 and not at x equals negative 7. So since it's only moving left 6 units, it would actually be x equals negative 6 versus x equals negative 7. So this one would actually be false. So you're going to focus on your parentheses. Now, if this would have said negative 6, I'd have put true. Okay. So this is sort of going back to the stuff we did yesterday, moving our graphs left and right. All right, here's one more for you. The graph of h of x equals x plus 3 squared can be obtained by translating the graph of h of x equals x squared. So remember, x squared is the basic graph. So can I obtain that by moving the x squared graph left 3 units? So true or false? So if they add 3 to the graph and attack that x like that, is that moving me left or right? Which will make this either true or false. And y'all, here's the trick.
True.
Yeah, because they're adding 3, which actually moves my graph left 3 units, which is what they said. So good job. That one is definitely true.
Can you go over why the second one? Can you just go over the second one again?
So remember, these basic graphs all started at the center of the, so our basic graph was a U-shaped parabola in the middle. So this is how it's moving with this x plus 6. So since that plus 6 is positive, remember when you square it and it's positive, that's actually going to move it left 6 units, just like this one did. They're just adding more stuff to it. But what that did, that's going to move this graph left over here to -6. And then that's going to be where the graph starts to go up and down. But if it moved it over here to -6, then that means the line of symmetry will cut it right in half at that -6. Well, they're saying our line of symmetry is over here at -7. So you focus on the parentheses, that tells you where your vertex is going to slide to, okay?
Okay.
All right, now here comes the, I guess you'd say, the big one of the day. So this problem, they want me to find the vertex, determine if it's a max or min value, and give that value. We're going to find the range. Intervals of increasing and decreasing. And then we don't even have to graph these ones. So let me tell you what's happening. When we look at the range, we're looking at the Y values. When we look at increasing and decreasing intervals, we're looking at X values. Like what X values is the graph going uphill, left to right? What X values is the graph going downhill, left to right? So that's what we're going to mean by those. So the first thing we'll do, and really on these, the vertex is going to sort of give me everything I need to know. So this function is f of x equals x squared minus 6x plus 5. Now remember, that's an x squared. So this graph will look like a U-shaped parabola when we're done. So y'all, let's start with our vertex and let's get that x value first. We know that x value is -b over 2a. So that's going to equal negative times -6 over 2 times our a, which is 1. So y'all, that's going to give me what, a positive 6 on top, positive 2 on bottom. 6 divided by 2 gives me an x value of 3. So I know the x value of this vertex here is going to be a 3. So now we're going to get the y value by finding f of that 3. So I'm going to put a 3 in for these two x's. I'll have 3 squared minus 6 times 3 plus 5. All right, y'all, 3 squared is 9. Minus 6 times 3 is 18 plus 5. So see, once again, that second number is twice as big as the first and opposite in sign. So 9 minus 18 is a -9. -9 plus 5 is a -4. So my vertex is 3, -4. All right, y'all, max or min? Well, since that was a positive x squared, I got a U-shaped graph. It has to be a minimum. And the minimum value is that y value of -4. Y'all, the range, remember the range is the y values. And notice, the smallest y value is sitting right here, and they head upwards. So on the range, we start with the smallest value and head up. So the range, now remember, the smallest y value I have here is that -4, and it has to be in brackets because we include that -4. So y'all, here's the question. My range starts at -4 on the y-axis, and it goes up and up and up. We say that's headed towards what?
Infinity.
Infinity. Good job. And remember, infinity always has to have a curved parenthesis. All right, so let's look at increasing. So think about this. Let's look like, here's our x's coming across like this. This graph starts increasing at the vertex, and as I head right, it's increasing and increasing and increasing. Now on these, we always use curves. So y'all, what I want to know is, what's the x value where this graph starts going uphill?
3.
3. And then as I go to the right, it's going uphill. I can keep going to the right. This graph is going to keep going uphill, uphill, and uphill. So these x's we say are headed off towards. What y'all think?
Infinity.
Infinity. All right, so just remember, when we're looking at increasing, we're looking at x values. When we're looking at the range, we're looking at the y values. Now, y'all, this one's going to be a little trickier, decreasing. I know where it stops decreasing at. It stops decreasing at that x value of 3. Because as I'm coming in from the left, it's going downhill, downhill, downhill until I hit that 3. So it's going to end at the 3 over here. So notice the decreasing ends at 3, and then it starts increasing at that 3. But y'all, the question is, these x's are coming in from the left side as I go toward that 3. What do we say these x's are coming in from on the left side?
Infinity.
Negative infinity.
Negative infinity. Good job. So and these will always have a negative infinity at one end and a positive infinity at the other, okay? Because you're coming in, because these parabolas, remember, these things go on forever out there, okay? So y'all, let's try another one of those and see how you do on that. So we're going to flip over and then make sure I move my camera up. So y'all, the same thing. We're going to find our vertex, determine maximum or minimum. We're going to find the range. And then intervals of increasing and decreasing. All right, y'all, but look, this time I'm going to have f of x equals a -4x squared minus 20x plus 9. And y'all, the whole trick on these to me is just being able to find that vertex. Now notice here, this is negative. That means this graph is going to flip over. So y'all, let's play with the vertex first. And let's get that x value. That's going to be negative b over 2a. That's going to be a negative times negative 20 over 2 times our negative 4. Oh, looks like we're going to have a lucky nutter fraction again, don't we? And that's going to give me a positive 20 over a negative 8. Ooh, that's going to reduce to a negative. And y'all, actually, I can take 4s out of both of these. So I'm going to divide both these by 4. So I get a negative 5 over 2. So the x value is going to be negative 5/2. And y'all, the y value, I'm probably going to plug in on my calculator because I'm finding f of that negative 5/2. That's going to equal negative 4 times negative 5/2 squared minus 20 times negative 5/2 plus 9. All right, I'm going to plug that one into the calculator. So let me quit this screen. So I got negative 4 times negative 5/2 squared minus 20 times my negative 5/2. Close parentheses, plus 9. All right, y'all, so I'm going to hit enter. And I get 34. So that don't even have a fraction. That's just going to be a 34. So when x is a negative 5/2, the y value is 34. All righty. Go back to the pad. So we know this point right here is at an x value of negative 5/2 and has a y value of 34. So next they want to know, is it a min or max and that value? Well, y'all, guess what? It was negative in the front. So we said that looked like an upside down parabola, which means it is definitely a max this time. And our maximum value is 34. But y'all be careful on my range. Remember, my range is my y values. And my y values are going up to a maximum of 34. So what's going to happen, the right side is going to be 34 with a bracket. My question is, these x's are coming from the bottom and heading up. Where are your x's coming in from? I mean, your y's.
Negative infinity.
Negative infinity. So on the range, it'll either be from the number to positive infinity, or it'll be, in this case, from negative infinity to that number. And y'all look at this. Now I'm looking at x values here. This graph is increasing on the left side. So this graph is increasing on the left side. So any guesses where I'm increasing from and to? Y'all, let me start you out. You're coming in from the left side.
Negative infinity to negative 5/2 with a bracket.
Oh,
Or-
just remember, on the increasing, decreasing, always use parentheses. but those numbers are perfect. And the reason we use parentheses is because that point can't be both increasing or decreasing. So since that's the point where it's changing over, when you're doing increasing and decreasing, you just use the parentheses, okay? But ooh, that's a good job, because that's all we're looking at is MX's. Now the range, that 34 is not being shared with anything else, so that's why we put it in brackets on the range. Do y'all want to try decreasing? Decreasing is this side going downhill. So where does it start decreasing at on your X's?
-5/2 to positive infinity.
The positive infinity, because as my X's go to the right, that graph's just going to keep going downhill. So good job. So notice on these intervals, from negative infinity to -5/2 is going uphill. And then starting at that -5/2 going to positive infinity, it's going downhill. So these are sort of be connected with that vertex X value being the crossover point, okay? So y'all, let me show you an application of this vertex formula. So the vertex formula, if I was looking for like the maximum area to build my dog pen or something like that, I could plot that, and the vertex would tell me what my maximum area would be and what to make my X values. Another application is in this little problem here. A toy rocket is shot vertically into the air from a launching pad three feet above the ground. With an initial velocity so velocity is sort of like speed, okay? So it's got initial velocity of 64 feet per second. So the height in feet of the rocket above the ground at T seconds after launch is given by the function h of t equals -16t squared plus 64t plus 3. So then they say, hey, how long will it take the rocket to reach its maximum height? So how long until rocket reaches maximum height? So they're looking at the time on it. And then they say, what is the maximum height? So y'all, all this stuff here is just explaining how they got this formula. That 64 feet per second, that's where they got the 64t. So every how many seconds, it's going 64 feet. This 3 here, well, they got a 3 here because the launching pad started out 3 feet above the ground. So it's like the little launching pads on a table, 3 feet above the ground, and then you got your little rocket here. Okay. But all that's just letting you know how they got this formula. Let me ask you all this. If this is how fast it's going, this is where height it started from. What do you think this negative 16t squared would be?
Time?
Well, the t is the time. T will be the time. But what do you think? What would be a negative? What would affect the height of this rocket? Right? That's how fast it's going. That's how high it started from. But what would make the rocket come in a negative direction?
When it's coming down,
Oh, I couldn't hear that.
when it's coming down,
Yeah, what's going to make it come down though?
gravity.
Gravity. So this negative 16t squared represents the gravity pulling on my rocket. This represents the speed of the rocket. And then that 3 was the height of it. But y'all, we don't have to know all that. Because guess what? This rocket starts off, as time goes up, it's going to increase and increase. Once it reaches the maximum height, it's going to start wanting to come back down. So to find that maximum height, I need to find the vertex of it, right? Because the vertex will tell me the maximum height, and it'll also tell me how long it took to get to that maximum height. So we're actually going to use our vertex formula to find these values, okay? So here's our equation. A is going to be that negative 16. B is going to be 64. And then C will be the 3. So I'm going to get the X value. Now remember, X is the same as the T on this, okay? Because they're giving me a variable of T, which represents time. So the time, which is the same as the X variable, will be negative B over 2A. So that's going to give me a negative 64 over 2 times a negative 16. Now, time, this T better come out positive, because remember, time goes positive, okay? We can't go negative into time. So this has to end up positive. So let's see, I get a negative 64 on top, negative 32 on the bottom. Negative 64 divided by negative 32 gives me a positive 2. So I know that the 2 is going to be my T. Yo, that means it's only going to take my rocket 2 seconds to reach that maximum height. Now, to find that maximum height, we're going to plug in a 2 for the T. So we're going to find H of 2. That's going to equal negative 16 times 2 squared plus 64 times 2 plus our 3. Oh, y'all, so let me see what I get. 2 times 2 is 4. When I square that 2, I get 4. 4 times negative 16 is a negative 64. 64 times 2 is 128. See, once again, twice as big, opposite in sign. And then at the end is our positive 3. So if you add negative 64 and 128, you get a positive 64. 64 plus 3 gives me 67, which means my rocket went 67 feet high in the air as its maximum. And then the gravity started taking over and it's starting to come downhill. So how long? Well, how long was 2 seconds? And they'll have the seconds there. So all you got to do is put in the 2. And then that maximum height, we said was 67 And then they'll have the feet there for you on that one. So y'all, that's the vertex. So the next section is a lot smaller. And really the next one, they're just getting you graphing a little bit, getting you good at graphing on some of these. So y'all, let me move this back up. And I will say that this 6.1 section is really small, okay? Oh, let me get my paper fixed. All righty, make sure I'm at the top. So 6.1 deals with radical expressions. So radicals we're looking at is just going to be square roots. So the first thing they want us to do is find the domain of a radical function. So this is the second thing I'm worried about on a domain. So the domain of a radical expression is all real numbers that make the radicand. Now the radicand is what's underneath the radical. So this would be the radicand underneath. But it's going to be all real numbers that make the radicand greater than or equal to 0. Okay, because if you got a radical here with an a under here, that means that this a has to be greater than or equal to 0. And y'all let me play with that. So recall. I'm just going to play with a few radicals with you. What's the square root of 4?
Two.
What is the square root of, say, 1?
1.
Square root of 0.
0.
Square root of -2. Can you do that one? And remember, my domain has to be numbers that make this a real number. But y'all, we can't do square roots of negative numbers, remember? If we do square roots of negative numbers, these things are imaginary. Right? And imaginary numbers you cannot plot on a graph. We need these expressions to give me real numbers so that I can graph it. And if you recall, when we was looking at the basic graphs the other day, remember the square root graph? It sort of started at the center and went to the right, uphill, barely going, but it was going uphill. But notice, it started at 0 because 0 is the smallest number I can take the square root of. There's no graph on this negative side on the basic graphs, okay? So just remember, when you're looking at the domain of a radical, it has to be set greater than or equal to 0. So y'all, let's play with one of those. We're going to determine the domain of each. Now I'm going to do more than one. The homework only has one for you to do, okay? But I'm going to do more than one, just so you get the idea. So what if I had f of x is the square root of x plus 3? So to find this domain, the first thing I'm going to do is take that x plus 3. And we said that underneath that radical had to be greater than or equal to 0. So y'all, then I would solve this. So let's see, to solve this, I'm going to subtract 3 from both sides. And this tells me that my x has to be greater than or equal to -3. So for this answer, I would have x such that x is greater than or equal to my -3, close parentheses. All right, so y'all get an idea? Watch this one. F of x equals a square root of 2x plus 1. So we know that this 2x plus 1 underneath has to be greater than or equal to 0. So I would solve this. Subtract 1 first. So I get 2x is greater than or equal to -1. Then I'm going to come in, divide both sides by 2. So that I now get an x greater than or equal to a -1/2. And basically, whatever answer you get here is what's going in your fancy parentheses. So x greater than or equal to a -1/2. So y'all, not too bad. You're just going to have one of them, and it's going to be sort of like this one I did. But that's a trick on finding the domain of a radical, because remember, we're not allowed to take square roots of negative numbers. Alrighty, y'all. So let me show you what I would do on these rest. Let me flip this over. And I think I'm going to go to Math Lab to work these ones. So let me find Math Lab, because this is a lot of graphing. So let me save that and go back to my screen here. All right, also let me get my share going for this one. All righty, so they want us to graph the function f of x equals 3 square root of x. So I'm going to do this on the calculator to see which one I get. Let me see my chat here. All right, I'll check that out in just a second. All righty, y'all. So on these, let's see. I would go to my calculator. I'll show y'all how to graph these. So I'm going to go to y equals and clear that out. So this was 3 square root of x. So I'm going to hit my 3, then second x squared to get the radical and throw my x underneath. And then I'm just going to hit graph. So y'all see that graph. So let's go find a picture. Y'all A, B, C, or D, that really looks like I'm going to play with it and go with the A on this. So let's look at my picture again. So see, it's making a pretty good, it's going up pretty good. Look at A here. Now, I'll tell you if you want to get it exactly right. You see how these y values go up to 15 on that one and -5 at the bottom? Watch what you can do on your calculator. If you want your graph to look just like that picture they're drawing, click this window. And my Y minimum was actually -5 that they did. So I'm gonna put a -5 there. Whoops, let me go back. That was X's. So X is -10 still. Arrow down to the Y minimum, make that a -5. Arrow down to Y maximum and make that a 15. If we make my window on the calculator look like the window on the graphs they're using, when we hit graph, we'll now be able to tell which one we got to go. So it looks like this goes up about 2/3 of the way on the right side. So y'all, let's go back and look now. So it looks like I'm actually going to go with A still. B looks like it's a little shallow for us, okay? All right, so you pick your graph, move on to the next.
Can you just do the first way you showed, or do we have to do that second thing with the windows?
Oh, you can do it the first way. You can just do, you can leave your calculator at regular settings.
Okay.
So like, now if I want mine to go back to regular settings, I just hit zoom and 6, that standard zoom. That standard puts everything back to normal. So now if you look at my window, everything's at -10 and 10. But no, they're the same either way. And look, if it's hard to tell, say let me go back to 2. Or I had that. So now they changed it to a 4. But same thing, I'd have probably picked my B on that. If B was wrong, then it has to be which one? D, don't it? Because it's going uphill to the right. So if it's hard to tell on your screen, it's going to be one of those two, okay? So that's sort of stretching it. But yeah, if you put the numbers to where they got them, then you can sort of tell a little easier. So y'all look at this one, -5 square root of X. Remember, that's a negative in the front. So that negative is going to flip your graph over. And only one of these pictures has my graph flipped over. So what would I go with? All right.
B.
Yeah, because watch this. When we go to our calculator, we had a -5 square root of X. And y'all, when you graph this in, there's only one flipped over like that. And y'all said that was, I think someone said B. So we would click B and move on. Oh, hell, I done had a 3 square root of X. So what do we go with that? And that was like the one I did first. Let's try A, because A is going uphill to the right. Bam, there you go. So how about this? And think about this. You had a basic graph that's a square root of X. What is that -3 doing to my graph when I attack it under that radical? It's like it's in parentheses. So when you subtract 3, is that going to move me left or right?
Right, 3.
Yeah, and there's only one that looks like it moved right. Which one is that? So see, they flipped it around. B sort of looks like it went down. C looks like, whoops, I don't want to click that. C looks like it went left. But y'all look at D. D actually looks like it went to the right. So we would pick D and then go to our next one. All right, so watch this. I'm going to graph this one on the calculator. So I got 3 plus 3x. So clear that. So now hit the square root first. And then I had 3 plus 3x. So we're going to hit graph. So notice it moved it left a little bit. So we're going to go look at which one went left and goes uphill to the right. So y'all, A, there's no way we're going to get a straight line like that. So are we going to go a B, C, or D?
B.
B, good job. And then you check that. And then let's see what 7's got. So that's the same thing, but it's a 3x minus 7. So let me go to y equals. And clear that out. So now I got a square root. 3x minus 7. I'm going to graph that one. So notice it went right a little bit and going uphill. So let's see what we want. A, B, C, or D?
A.
A. So that's the only one that looks like it shifted right and going uphill. The reason theirs looks bigger is because remember, they're only going to 5s on those Y values, okay? To where we was at 10 on ours. And y'all, that's all you're doing in this section is just one domain problem and then doing all this graphing, okay? Just getting you good at putting them square roots on those calculators. All right, y'all, so 7-5's a little trickier with the vertex. 6-1 only had like 5 or 6 problems, one doing the domain and the rest were doing picking which graph, okay? All right, so now I'll look at any questions y'all have. So I'm going to stop my recording so it'll start uploading.